Yes. Next sample question paper 3, question number 13. So read the question. Suppose that Rahul has a concave mirror and he places an object between the focus and center of curvature. Like that, the same question we discussed in the sample question paper 1, but there they didn't give about the position of the object. But here clearly they gave the position of the object. Clear? So read the question once again. Suppose that Rahul has a concave mirror. Concave mirror means we all know that when the reflecting surface is curved inwards. That type of mirror will be calling it as the concave mirror, and will mark all the terms over here. This point will be calling it as pole, this point will be focus, and this point is going to be center of curvature, and this line will be calling it as the principal axis. Where he is placing the object? He is placing the object between focus and center of curvature. That means the object is located in this place. So draw the respective diagram. So this is going to be A and this will be B. Take the reflected ray passing through the focus, strikes at the pole, reflect back by making the same angle with respect to the principal axis, and this is going to be A dash, B dash. So this is about the question what they gave. Clear? What happens to the image in the situation they are asking? In this specific situation, we are going to say about the image. So what is the nature of the image? Either it is real or virtual? Real. So now go to the answers what they gave. The image formed is always real. In the situation they are asking. What is the answer? Either A or B. A the answer. The reason they didn't change the position of the object. Clearly they mentioned over here in this situation, but in the previous question number 1, by the time you saw that he is using a convex lens, and what is the nature of the image they are asked. By the time our answer will be, our image either it can be real or virtual depending on the position. But here clearly they mention the position of the object. Object is located between focus and center of curvature. For this situation, always the image it will be real. That means answer for this question it is option A. The image formed is always real, inverted, magnified. Suppose the same question is there, but instead of center of curvature, they gave it as pole. Like this it is there. Again draw the respective diagram. Pole, focus, center of curvature, principal axis. So where the object is located between focus and pole means you just draw this diagram and then make the reflected rays to appears to meet like this. So the A, B, A dash, B dash. If today's question is changed like this means what will be the answer? Option B. The image is formed is always virtual, erect and magnified. Suppose if it is located, instead of giving the term like this, they gave it as beyond C. By the time what will be your answer? Eva, beyond C. A, B, C or D? D. Reason it is beyond C means this represents it is the second position. Just look at the image what is formed in the second position. If you are placing the object beyond C means you will be getting the image in this place, real, inverted and diminished. That means our answer will be option D. If they change the question like that means. So, read the question. Imagine Sandeep is examining a concave mirror. First draw the diagram. So, what mirror it is? The mirror it is called as concave mirror when the reflecting surface is curved inwards. And mark all the terms also: pole, focus, center of curvature, and this line will be calling it as the principal axis. Just use the different colors. Pole. And this distance will be calling it as radius of curvature. This distance will be calling it as f. And if this is f, means this also must want to be f. The reason it is, the focus is located at the midway. Midway in the sense the center point between center of curvature and pole. That means for example, if this is 5 centimeter, means this one also must want to be 5 centimeter. We will just write the data over here. CF, that means center of curvature, and focal length is going to be f, and focus and pole also is going to be f. So, now read the question. How does he wonders about the relationship between center of curvature and focus of the mirror. He wonders about the relationship between the center of curvature and focus of the mirror. Which option correctly represents the distance between center of curvature and focus? Go to the option. Equal to the focal length. Option B, half of the focal length. Option C, double of the focal length. Option D, it varies depending on the size of the mirror. This one it won't even be an answer. What will be your answer? A or B or C or D? C or? How many of you saying A? B? C? This is the wrong answer. Clear? A is the correct answer. So, we all learnt radius of curvature is 2 times of focal length. Most of the students will write this answer, but that is the wrong answer. Reason it is in the question what they asked. Which option correctly represents the distance between center of curvature and focus? This distance. What is this distance? F. This one will be equal to F. That means what will be the answer? Equal to focal length. For that only I wrote over here. Even that also people saying wrong answer. So, the option it is A. So, read the question. Assertion: the direction of the magnetic field inside a current carrying solenoid is from south to north. So, let us take a solenoid over here. Let us connect along with the battery. This end is going to be positive and this end is going to be negative. So, as per the rule, this end must want to come it as north pole and this end must want to come it as the south pole. We will be drawing the magnetic field lines. So, we all knows that outside the solenoid magnetic field lines will move from north pole to south pole. Inside the solenoid the magnetic field lines will move from south pole to north pole. Now, go to the assertion again. The direction of the magnetic field inside the current carrying solenoid is from south to north. They said that only. That means assertion is true. Now, come to the reason. The strength of the magnetic field produced in the solenoid, that means magnetic field they are saying it is directly proportional to the number of turns. That is what he learnt. And what are the factors the magnetic field depends upon? Means one, it depends upon the current and another one is depends upon the number of turns. How it is going to depend upon? When magnetic field is directly proportional to current as well as the magnetic field is directly proportional to the number of turns. That means if the number of turns is increased, magnetic field also will get increased. In the question also they said the same. That means reason also it is true. Either our answer it is A or B. B. The reason it is assertion says about the direction, reason says about the strength. Both are different terms. So both A and R are true, but R is not the correct explanation of assertion. That means our answer will be option B. Next. Yes. What is the significance of the principal axis in a ray diagram for determining the position and the nature of the image? We'll just take one condition alone, because concave only will produce both real as well as virtual. Pole, focus, center of curvature, and this line only is going to play a major role over here, principal axis. Lens. Optical center F1, 2F1, F2, 2F2, and this line will be calling it as the principal axis. Now, and let us take the convex lens also. Optical center F1, 2F1, F2, 2F2, and this line will be calling it as the principal axis. So first let us draw one diagram for concave alone. Let us take the object is located anywhere in front of the lens. Let us take like this. So the light ray will passes parallel to the principal axis, it will get diverged, and then it will appears to passes through the focus. Passes through the optical center, it will goes in a straight line without any deviation, and here we will be getting the image. So this is A, and this is B, and this is A dash, and this one is B dash. Like that we will draw one more diagram for convex lens also. We will take the object is located at 2F1, the image also will be formed at 2F2. So A, B, A dash, B dash. Clear. This is for your reference alone, you are not going to draw the same diagram in your paper. Now, in the question what they asked, what is the significance of the principal axis in a ray diagram for determining the position and nature? First, let us say about the position of the image. If it is located on the left side, clear, it represents, it is negative. Sorry, position, right? This distance you should not take, you need to take it as above the principal axis. If it is located above the principal axis, this represents, it will be positive. The reason it is going to lie along the y axis. We all know that in a graph representation, y axis it will be positive and y dash it will be negative. So first we determined about the position. Next we are going to say about the nature. If it is located above the principal axis means either it is real image or virtual image. Virtual. they didn't ask about the where the image is located. Yeah, that is not the question. What is the significance based upon the principal axis? What type of image you are going to get? Clear? That is the question. So either you need to say it is located above the principal axis or below the principal axis. Above the principal axis means either it will be positive or negative, and if it is above the principal axis means what is the nature of the image. That's what you are going to say. Whereas here in this diagram, the image is located below the principal axis. Below the principal axis means it is going to be negative, and the nature of the image is going to be real. Nature of the image is real. The reason it is, what is the reason? They are appears to meet or actually meeting? Actually meeting. Here appears to meet. Next, second question. Explain the concept potential difference and how it is measured by using voltmeter. So already we learned about the term called as potential difference. What is meant by potential difference? The amount of work is done to move a charge from one point to another point. Against electric force. This word is very important. If you are not writing this word against electric force, sure they will reduce the mark. Next. So this is a statement what you are going to write, and in the question another one part they asked how it is measured by using the voltmeter. So how we are going to connect the voltmeter? Suppose we are going to measure the potential difference which is created across in the conductor means we need to connect the voltmeter in parallel across the ends of the conductor. This statement you need to write, and then you need to draw the diagram. The voltmeter must only be connected in parallel as well as across the ends of conductor. This statement you need to draw how to connect that one. Next question. So read the question carefully. Imagine you are a presenter at a science fair and you have to set up an exhibit to explain the concept of focal length. So first question, we are just going to explain what is meant by focal length. So by using what lens we are doing this one? In the question they said it as convex. So we need to determine the concave also is given. But concave we can't able to determine the focal length. The reason it is since it is a diverging lens we can't determine. Let's prove for the convex alone. So what we are going to do? We are going to take a convex lens, that means when the refracting surface is curved outwards. So we need to choose an object which is located at infinity. When the light rays are coming from infinity, after refraction the light rays will start to converge and then it will fall at one specific point, and that point only will be calling it as the focus F2, and the distance will be calling it as the focal length. So this one you need to write in a statement. So what you are going to do? We are going to consider an distant object, and that distant object when the light rays are coming from infinity, so after entering into the lens, the light rays will get converged and then it will fall at one specific point, and that point is called as the focus, and the distance between focus and optical center is called as the focal length. Like this you are going to write over there. And so second question what they asked, at your science fair exhibit, how would you describe the concept of focal length and the role to determine the convex and concave lens? For concave we can't prove the focal length. The reason it is, when the light rays are coming from the infinity, the rays will start to get diverged. If it is getting diverged means we will make them to appears to meet. Appears to meet in the sense, here we are going to get a virtual image. Here we are going to get a real image. A real image can be captured on the screen. That means it can be obtained on the screen, whereas virtual image cannot form on the screen. We cannot able to obtain the virtual image on the screen. This is why we can't able to determine the focal length of a concave lens. This constraints only are going to give constraint in the sense, there is a reason you need to say why we can't able to determine the focal length of a concave lens. Question number 32. Rohan is examining an electric circuit. The circuit is made up of 3 resistors. Totally how many resistors are here? 3 resistors. So what are the 3 resistors? R1, R2 and R3. So in the condition they said clearly all the 3 resistors are connected in a form of series. Clear? The first resistor has a resistance of 10 ohm. The second resistor has a resistance of 15 ohm and the third resistor has a resistance of 20 ohm. Rohan wants to calculate the total resistance. That means net resistance we need to calculate. So what is the formula? R is equal to R1 plus R2 plus R3. What is the value of R1? 10 plus 15 plus 20. 10 plus 20, 30. 30 plus 15, it is going to be 45 ohm. So the net resistance is going to be 45 ohm. Next, determine the current flowing through it when it is connected to a potential difference of V is equal to 12 volt, as well as when it is connected to a battery of V is equal to 24 volt. So they said 2 cases. Let us take it as V1 and this one is said take it as V2. If all the 3 resistors are connected to V1, by the time what will be the current? If all the 3 resistors are connected to V2, by the time what will be the current? First let us take the case 1. In case 1, what is the value of potential difference? V is equal to 12 volt. What is the net resistance we calculated? R is equal to 45 ohm. Now Ohm's law formula, V is equal to I into R. I value only you are going to calculate. So I is equal to V. Here R is in multiplication, while coming to the other side division, V by R. So I is equal to, what is the value of V? 12 by, what is the value of R? 45. Check whether you can able to simplify. Yes, 3 table, 4 3s are 12, 15 3s are 45. We can't simplify further. Go along with the normal long division method. We'll be using. So 4 divided by 15. Answer is going to be I is equal to 0.66 ampere, or we can write it as 0.27 ampere. So like this, calculate if the for case 2 also. What is the value of potential difference? V is equal to 24 volt. The net resistance will be the same as it is. R is equal to 45 ohm. Use the same formula. V is equal to I into R. I is equal to V by R. I is equal to 24 by 45. Check whether you can able to simplify. 3 table. 8 3s are 24. 15 3s are 45. So you can simplify further. So go along with normal long division method. So the 8 divided by 15. Answer is going to be 0.533 ampere, or we can say it as 0.53 ampere. This one is lesser than 5, so you can skip that number. Here it is greater than 5, so we added plus 1. Next, so the question over. So in the question what they sent, describe 2 real life applications. Real life application in a sense in our day to day life where we are applying parallel combination. Where you are using the combination what is given in our schools, what type of combination it is? In our home, in schools, in laboratory, in these places we are using the parallel combination of resistor. Provide an example of a situation where this agreement is an advantage and explain how it is work. First let us write what is the advantage of parallel combination. So the various advantages of parallel combination are, the first advantage is that the potential difference will remain same, and second advantage is that each device will take appropriate amount of current to operate. The reason it is, since the potential difference is going to be same, the value of current will eat how much amount of current. That means in our domestic circuit the potential difference is going to be 220 volt. If potential difference is more, means by the time the current flow also will be high. Each device how much amount of current it needs, it take that much amount of current. And the next advantage is that separate switches can be provided for each device. And next one is that if one device got damaged, the other device will work or it won't work? Will work. Next, since we are providing the separate switches for each device, we can save energy, and then the next advantage is that the net resistance will become low in parallel combination. Clear. So these are the advantages and how it is going to work over there. How it is going to work means if one device got damaged means the other devices will continue to work. So this is the advantage of the parallel combination. Next. So read the question. A student intends to project the illumination of a candle flame onto a screen located 60 centimeter in front of a mirror. So on mirror is then, by using that mirror they are obtaining the image of the candle at a distance of V is equal to 60 centimeter. But in the question they didn't mention either it is concave mirror or convex mirror. How we can identify the mirror what we are using, either it is concave or convex? Screen. The word what is given over there, right? This word only is going to play a major role in order to find the nature of the image. Screen means it represents the nature of the image, what you are going to get, it is called as real. That means if it is real means the mirror what we are using, it is called as concave and it is not convex. The reason it is convex will produce only virtual. Virtual image cannot be formed on the screen. That means the nature of the mirror what we are using here, it is called as the concave. Now write the datas. V is equal to, since it is a mirror, real image means it will be there on the left side from the pole. If it is there on the left side means either it is positive or negative? Negative. So V is equal to how much centimeter? 60 centimeter. Plus 60 or minus 60? Minus 60. The student position the flame at a distance of, the student position the flame at a distance. Position the flame in the sense that flame is considered as the object. So the U is equal to 15 centimeter. Always the object will be located on the left side. Since it is there on the left side, this one also is going to be negative. So in the question what they are asking, first condition we are going to identify the nature of the mirror. So let us write over here nature of the mirror. Already we said the nature of the mirror, it is concave. The reason it is the image is formed on the screen. Concave mirror only is having an ability to get a real image. Clear? This reason you need to write along with the answer. Calculate the linear magnification. Magnification and linear magnification, both the meaning are same. Clear? So what formula we are going to use for the second one? So M is equal to H dash by H. For calculating the magnification we are having two formulas. M is equal to H dash by H, that will be equal to minus V by U, and M is equal to H dash by H, that will be equal to plus V by U. One is for lens and another one is for mirror. Out of these two formulas, which let us name the formula. Let us take it as 1, let us take it as 2. In these two formulas, which one you are going to use in order to calculate the magnification? Either 1 or 2. We are going to use the formula 1. Clear? This is the formula what you are going to use in order to calculate the linear magnification for mirror, and this is the formula what you are going to use in order to calculate the linear magnification for lens. Here optical device they set it as a mirror. So what formula we are going to use over here? So M is equal to minus V by U. Now substitute over there. So M is equal to minus, what is the value of V? Minus 60 by, what is the value of U? Minus 15. Minus into minus plus, plus by minus, minus. 1 15s are 15. How many 15s are? 4 15s are. So, m is equal to minus 4. What is the unit of magnification? No unit. Along with that, you just write this also. M is equal to minus 4 and does not have any unit. We need to write it as a no unit over there. So, now determine the separation between the object corresponding image. Separation in the sense it represents, it is the distance. Clear? Distance between what? Distance between the object and image you are going to determine. Let us take like this. So, what mirror we identified? Concave mirror. So, this point we will be calling it as pole, focus, center of curvature, and the line, what is that line will be calling it as the principal axis. So, the object is placed at a distance of 15 centimeter from the mirror. Since it is located on the left hand side, it is going to be minus 15. Clear? And the image is formed at a distance of V is equal to 60 centimeter. Now, we need to find what is the distance between object and image. How we can calculate this one? If two lines are there, one line is like this and another one line is like this. This line is having a distance of 10 centimeter. This line is having a distance of 5 centimeter. I need to identify what is the remaining segmental. How I can find? 10 minus 5. Same as it is. Here one line is there which is having 60. Here one line is there which is having 15. I need to find this line alone. So, how I can calculate? 60 minus 15. 60 minus 15 is going to be 45. So, the distance separation between object and the image is going to be 45 centimeter. Minus 45 line. Distance only they are asking, no? Distance means always you need to say only in a form of a positive. Yes. We'll scan the question again. So, 1 up to 3 already we completed. Next one, what we need to find? We need to accompany a reason with a ray diagram that illustrates the process for the formation in this scenario. Clear? So, the same ray diagram you need to draw. So, what mirror it is? Concave mirror, and after drawing that one, mention all the terms: pole, focus, center of curvature, and draw the principal axis. Where you are going to place the object? You are going to place the object beyond C. How I determined, not beyond C, between C and F. How I determine this one? Distance, focal length. How we determine the object is located between C and F? Even I got the magnification. M is equal to minus 4. Minus means it represents it is real. Clear? For the first 5 position, that means even if I am placing the object at infinity or beyond C, at C, between C and F, at F, for all the 5 positions I am going to get the real image. How I can confirm the object is located between C and F, I am asking. How we can confirm that one? Simple. Okay. Don't think too much. Here. N. N value is greater than 1. We all know the condition. N value lesser than 1, N value equal to 1. If it is greater than 1 means it represents it as enlarged. If it is lesser than 1 means it represents it as diminished. If it is equal to 1 means it represents it as same size. If I am placing at infinity means it will be highly diminished. But the factor what I got over here it is 4. If it is beyond C means it will be diminished. Diminished in the sense it must only be lesser than 1. Here it is greater than 1 or lesser than 1? Greater than 1. If I am placing at C means I will be getting the factor as 1, but here I got it as 4. Next, if I am placing the object at F means the factor it will be infinity, highly enlarged. Here only it will be greater than 1. So, this is how we need to confirm the position where you are placing the object. Clear? Even you can draw the diagram over here also. Suppose if you are placing the object in this position means they won't even provide the mark for the fourth one. Clear? Remember the condition carefully. M is equal to minus 4. Minus represent the nature of the image is real. In that 5 positions I will be getting real, and this 4 represent the nature of the image is going to be, size of the image is going to be enlarged. At what position I need to place the object in order to get the enlarged means I need to place the object between C and F. That means you are going to place the object between C and F we placed, and then draw the respective diagram. Incident ray passing parallel to the principal axis. After reflection it will passes through the focus. Incident ray strikes at the pole, reflect back by making the same angle with respect to the principal axis, and then draw the rays and connect the point where the two reflected rays are meeting, and draw the line over here and mention this is the head of the image A dash and this is the tail of the image B dash. And over here also you need to mention head of the object as A and tail of the object as B. Suppose I calculated the magnification and I got it as minus 0.5, like this I got. Clear? Where I need to place the object for this condition? Beyond C. The reason it is minus. Minus means it is going to be real. Okay, for the first 5 positions only you will be getting real. 0.5. 0.5 is lesser than 1. Lesser than 1 means I need to get a diminished image. So, where I need to place the object? Beyond C. Suppose I got the factor like this, M is equal to plus 1.5 between F and P, plus what it is? Virtual. In order to get a virtual image, where we need to place the object? Between F and P. I got the magnification as M is equal to minus 1 at C. 1 minus real, 1 same size. In order to get the same size, where I need to place the object? Who is that between? Between, always between. At C then. Hey, that condition alone remember clearly. M is equal to plus R minus N. Plus means it represents, that means positive. It represents the nature of the image is virtual. That N value 8 and then minus. Minus means it represents the nature of the image is real. Next condition, the factor N it can be greater than 1, N it can be lesser than 1, N it can be equal to 1, N it can be very very greater than 1, and N it can be very very lesser than 1. Greater than 1 means it represents the size of the image is enlarged. Lesser than 1 means it represents the size of the image is diminished. Equal to 1 means it represents the size of the image is same. Very very greater than 1 means highly enlarged. Lesser than 1 means highly diminished. So, these are the conditions. If you are getting the answer, that one is writing. Yes. 6 positions is there at infinity, beyond C, at C, between C and F, at F. So, these are the 5 positions I can get a real image, and between F and P, this is the only position where you can able to get a virtual image. Clear? Now, case 1, if you got the answer like this, m is equal to minus 1, like this it is there. Minus means minus real. So, our answer is going to be any from this 5, any 1 is going to be our answer. 1 represents it is same size. So, if you are placing the object at infinity, our image it will be highly diminished. Beyond C, diminished. At C, same size. Between C and F, enlarged. At F, highly enlarged. Here it is going to be enlarged. Now come to the condition. M is equal to minus means it is going to be real. So, anywhere our position is going to be in this phi, and this represents it as virtual. So, I got the value as 1. 1 means it represents same. That means where you need to place the object at C. Now, second condition, M is equal to minus 0.5 beyond C. M is equal to minus 1.5 between C and F. M is equal to plus 2.5 between F and P. M is equal to plus 0.5. Is it possible to get by using a concave? No, it's not at all possible. The reason it is, if you are placing the object between C and F, our image it will be enlarged. That means the factor must want to be greater than 1, but here the value I gave it as lesser than 1. This is possible. For which mirror it is possible means it is possible for a convex. Reason, plus represents it as virtual, 0.5 represents it as diminished. So, which mirror it is called as the convex. Another one condition, M is equal to plus 1 plane mirror. So, read the question. Mark is studying the principle of electricity. He counters the passage with the valuable information about the electric current, electric potential and potential difference. Electric current is a term used to denote the rate at which the electric charges move. You just read the full paragraph what is given. We will go to the question alone. Mark is tasked with the defining electric current. Defining electric current or define electric current, all the meaning are same. So, what is meant by electric current? Electric current is defined as the rate of flow of charges. Rate of flow of charges is called as electric current. So, I is equal to Q by T. This rate is nothing more called as, with respect to some time only the charge is going to flow. You are, after writing the definition, write the formula and write the unit also. So, what is the unit of electric current? The unit of electric current is ampere, and then mention along the symbol A, or based upon the formula if you are going to write means coulomb per second. Now, next question what they asked, stating its SI unit. Stated the SI unit means you are going to define the unit of current. That means you are going to define this ampere. So, what is meant by 1 ampere? 1 ampere is defined as 1 coulomb of charge is flowing through the conductor in 1 second is called as 1 ampere. Next. Second question, explain the relationship between the direction of current flow and the movement of electron within the circuit. So, this concept is based upon the directions of the current. We know the two directions of current are there. What are the two directions of current? Conventional current and electronic current. Electronic current we can also call it as the electron current. Clear? Conventional current always flows from higher potential to the lower potential. That means from positive terminal towards the negative terminal, whereas the electronic current will flow from lower potential to a higher potential. That means from negative to a positive terminal. So, what is the relation? Always the direction of current will act in the opposite direction of the movement of electron. That is the reason you are going to give. Next. Mark is tasked to define electric potential. Again the same repeated question. What is meant by electric potential? The amount of work is done to move a charge from one end to another end against electric force is called as electric potential. After writing the statement, you need to write that formula V is equal to W by Q and describe the concept potential difference. The same you need to define and provide the SI unit. The unit of electric potential also it is volt, and potential difference also it is going to be volt. Clear? Next, last question. Mark is tasked to calculate the potential difference across the resistor when a charge of 5 coulomb. Charge is represented by the letter Q. Q is equal to 5 coulomb and is through the resistor dissipates 25 joule of energy. Energy is equal to 25 joule. Express your answer in a form of volt. We all know that energy we can also write it as work. So, these are the three conditions are there. What formula we can use over here? V is equal to W by Q. So, write the formula V is equal to W by Q. What is the value of W? 25. What is the value of Q? 5. 1 5s are 5 5s are. So, V is equal to 5 volt.